In this video, I'm going to solve these ordinary differential equations. So I'll start by the first one here, this first order ODE. So to solve it, I'll enter the MATLAB code, create a symbolic function. Because what we are having here is the x is the independent variable. I then go on and enter the differential equation, and I'll call it D1. So D1 is equals to, then for the differential equation, we type in diff, open parenthesis, we are differentiating y with respect to x. We define the equation using a double equal sign. So I now go on and type what is on the right hand side there. We're having x multiplied by y plus x plus y plus 1. So this is what is on the right hand side. I can just run to see the differential equation that I've just entered. So we are having the derivative of y there with respect to x, then x plus y of x plus x times y of x plus 1. So after entering the equation, I then go on and solve it. So I'll call the solution S1 is equals to, the function for solving differential equations that I'll use is dsolve, open parenthesis, and we are saying we are solving D1, differential equation 1. Then I go on and run, and it gives us the solution there. The S1 is equals to C1 multiplied by exponent of x times x plus 2 divided by 2 minus 1. What I did here is I entered the differential equation first, then put it here with the D1. But it is possible to write this differential equation directly in the parentheses here. But I avoid writing it directly in the parentheses or avoid making mistakes. Because writing it first, then I check it. If I have entered it correctly, then I go on and solve. I find it better that way. But if you want, you can just type the equation directly inside this parenthesis. I now move on to this second differential equation where we are given an initial condition. So I'll go on and enter the code. So for the code, we have already created our function there, y of x. So I just go on and enter the equation there. So for the equation, I'll call it D2 is equals to diff, open parenthesis, and what we are differentiating there is the y with respect to x. Define the equation by the double equal sign y to the power 3. So that's the differential equation. I can just run just to confirm. So this one, the derivative of y with respect to x is equals to y to the power 3. Then I'll go on and enter this initial condition. So I'll call it cont 1 is equals to y, open parenthesis, at 0. Then that equation, we define it by double equal signs, is equals to 1. I press the return key. Then now go on and solve our solution. I'll call it S2 is equals to D, solve, open parenthesis, we are solving D2. But put in the condition there, and our condition, we say this is cont 1. So we are solving this differential equation under this condition here that we are given. So I go on and run, and it gives us there the solution is root 2 multiplied by root of minus 1 divided by x minus 2 divided by 2. I now go on to the next one. So I'll go on and enter this differential equation, and I'll call it D3 is equals to the differential equation where we are differentiating y with respect to x, then minus y. Then we define the equation by double equal signs, x multiplied by y squared. So that's the differential equation. I can just check if I have entered it correctly. So we have the derivative of y with respect to x minus y is equals to x multiplied by y squared. It's saying y parenthesis x just because it's saying y depends on x. Then go on and solve the differential equation, and I'll call the solution S3 is equals to d solve, open parenthesis, we are solving d3. So for the solution of d3 there, I'll go on and run, and it gives us the solution for d3 there is exponent of x divided by c1 minus exponent of x multiplied by x minus 1. And the other one is just a zero solution there. I now go on and solve this second order ODE, y prime prime minus 4y prime plus 5y is equals to 0. I enter the code for solving that ODE, so I'll call this differential equation d4 is equals to, so our d4 there, we are having the derivative of y with respect to x is the second derivative, so we put comma 2. So that's the command for the second derivative there. Minus 4 multiplied by the derivative of y with respect to x. This is just a first derivative, so we don't write anything there. Then plus 5 multiplied by y. And then we define the equation by double equal signs. And just run to check if I've entered correctly. And we have there the second derivative of y with respect to x minus 4 times the derivative of y with respect to x plus 5 multiplied by y is equals to 0. So when I've entered the equation, I go on and solve it, and I'll call that solution S4. So for the S4, it will be d solve, open parenthesis, we are solving d4. The differential equation that I've called for there, then I go on and run, and it gives us the S4 there is C1 exponent of 2x multiplied by cosine x minus C2 exponent of 2x multiplied by sine x. I now go on to the next one there. We are having a second order ODE, but given these conditions there. So I'll enter the code for solving that ODE. So for the code, I enter the differential equation and I'll call it d5. So my d5 will be equals to the derivative of y with respect to x. This is the second derivative, so I specify the 2 there, then plus the derivative of y with respect to x, and then minus 2 multiplied by y. Define the equation by double equal signs is equals to 0. I just run to check if I've entered it correctly. So we have the second derivative of y with respect to x plus the derivative of y with respect to x minus 2 times y is equals to 0. I then go on and enter these conditions there. So to enter those conditions, I'll type in dy is equals to diff open parenthesis y. That's the first step there. Then enter the first condition here, this one, y at 0 is equals to 9. So I'll call it condition number 2, since I already have another condition 1 which is appearing here. That's why I'm saying condition 2, because I already used condition 1 above. So condition 2 is equals to y, open parenthesis, at 0. Define the equation by double equal signs is equals to 9. I press the return key. Then condition 3 is equals to dy at 0. Define the equation by double equal signs. Here is saying the derivative of y at 0 is equals to 12. So it's dy at 0 is equals to 12. Then the next step is to write those conditions there as 1. So I'll call it conditions is equals to, then open square brackets, cont 2 space cont 3. Press the return key. Then I go on and now solve. So this will be my S5 is equals to D solve, open parenthesis. We are solving a D5 under the conditions that we have there. These conditions, y naught equals to 9, y prime not equals to 12, which we have defined here as const. So I go on and run, and it gives us the solution there. S5 is equals to 10 exponent of x minus exponent of 2x. So that's the solution there of this ODE given these conditions. I will now go on and solve this system of linear equations. So to solve that system of linear equations, I press the return key there so that I enter my code. The first step there is to create symbolic functions. So I type in sy ms. The symbolic functions that we are creating there is x, which is a function of t. We are saying x function of t because t here is the independent variable, and the other one is y, is a function of t. So those are the two symbolic functions that we need there. And then I go on and enter this equation here. So I'll call it ODE 1 is equals to the derivative of x. In this case, there is no need of specifying that the derivative of x with respect to t, like what we're doing here, we say with respect to y. Because if you don't say with respect to what, MATLAB takes t as the default independent variable. So in this case, there's no need to write that down, because MATLAB will take t as the default independent variable. So it's the derivative of x with respect to t. We'll define the equation by double equal signs. So it will be minus 2 multiplied by x, then plus y. So that's the first ODE there. Then the second one is ODE 2 is equals to the derivative of y. We don't specify again here because MATLAB will automatically take t as the default variable. We'll define the equation by double equal signs. So it will be 5 multiplied by x plus 2 multiplied by y. So we have entered our equations there. I can just run to see if I've entered those equations correctly. So we have our ODE 1 there is y minus 2x. Then the other one there is 5x plus 2y. So I've entered those ones correctly there. I'll go on to the next step is now to combine those ODEs to have one system. So I'll write them as ODEs is equals to open square brackets ODE 1 semicolon, then ODE 2. So we have written now them as a system there, ODE 1, ODE 2. And then we go on to solve, and our solution, we'll call it S6, the sixth solution that we are having here. And we use the function dsolve. Dsolve, open parenthesis. What we are solving here is ODEs. The system there that we have defined here. So dsolve ODEs, then I go on and run. And it gives us the solution there. For the y, it's C1 exponent of minus 3t plus C2 exponent of 3t. Then for the x is C2 exponent of 3t divided by 5 minus C1 exponent of 3t. So that's the solution there for this system of ODEs.